it shut off again. I think the thing was just running out of memory, so I deleted some old videos, and now I think we'll be good. So, like I was saying, since we've been assuming that when we hit the water that was positive velocity, if I jump upwards, that's a negative velocity. So I'm jumping, so this will be a negative 2 meter per second velocity, and then I'll fall the 10 meters. How fast am I going to hit the water? So we just go through that same process. No acceleration is 9.81 meters per second squared. If I do the antiderivative of that, my velocity will be 9.81 times t plus a constant. Now here's where it's different. Here we assume at t equals 0, so when t equals 0, I know that this isn't like, this is hard to think about this way. You could think about when t equals 0.000000001, what's my velocity? Well, the velocity then would be the negative 2 meters per second. So right when the clock ticks, right when my foot leaves the ground, my velocity is negative 2 meters per second. So I'll plug that in. So v is negative 2, 9.81 times 0 plus c. That's just 0. So in this case, I do have a c. It's negative 2. So my velocity equation is 9.81 t minus 2. So now when I go ahead and do my antiderivative again to get my acceleration, or excuse me, position function, I'll go again 9.81 over 2t squared, and it'll be minus 2t plus c. Hopefully you're seeing how to do that antiderivative thing. You just got to think, okay, when I take the derivative of this, how am I going to get that? These are pretty simple ones. And so here we go again. When t equals 0, what's my position? My position, well, when t equals 0, my position is still 0. So 0 equals 0 minus 0 plus c. c equals 0 again on this one. So my position function is the 9.81 divided by 2, so 4.905 t squared minus 2t, and c is 0. Well, okay, so now, again, I want to find out, after I fall 10 meters to the water, how fast am I going? So I'll plug in 10 for p, 4.905 t squared minus 2t. Now I got to solve that for t, and I hope you're not thinking, oh great, I got to do quadratic formula. Well, no you don't. 0 equals 4.905 t squared minus 2t minus 10. Yeah, normally you'd have to do quadratic formula, but we're over that now. We have calculators. This is a calculator problem. So quickest and fastest way would just be graph it. Luckily, hey, I already did it. It's already in here. Graph it, and then find the zeros, right? Hopefully you remember how to do that, and I don't have to explain that anymore. We don't care about the negative value of t, because we're not going back in time. All we care about the positive value of t, so if I do calc 0, left bound, right bound, guess, hey, there it is, x equals 1.64, or t equals 1.646. So now same thing, take that t, plug it back into my velocity equation, so v equals 9.81 times 1.646 minus 2, and if you do that, you should get, I think it's like 14 point something. You'll get velocity 14.147 or 15 meters per second. So a little bit faster, well, because you jumped in the air, so you know, when your velocity hit 0 and you started falling again, you were a little higher than 10 meters. We could do some more stuff with that, which we probably will later. But for now, that's good. I think you have one problem like that on your homework. I am looking for it. Where did I write down the homework? Oh, there it is. Oh, maybe I didn't give you a problem like that yet. I should. That's okay. Okay, here's your assignment. Let's go 5.1, just because you're going to have a quiz on it next week, so you can't forget that. Number 2642, and then in 5.2, do numbers, quick review 1 through 10, and numbers, let's see, got to include the ones I chopped off yesterday, because we didn't get far enough. Let's see, what did I give you yesterday? I'm going to give you up through 9, so we'll go 12, 15, 16, 18, 15, 16, 18, that's from yesterday, plus the stuff from today would be 7, 11, 22, 25, 31, 32, and, well, I'll leave off. Could do, no, that's plenty. That's a long assignment. So there you go. Enjoy that. I think that's all I have to say about that. See you Tuesday.